Welcome to the Economist in Your Ear podcast. Have you ever paused to wonder what truly happens to your old phone, tablet, or laptop after you upgrade? We're constantly hearing about the incredible promise of robots and AI making our lives easier, but can they actually tackle something as intricate and complex as disassembling all that electronic waste efficiently and sustainably? Today, we're taking a closer look at a recent piece from The Economist that suggests AI-powered robots can take your phone apart.
It's a compelling headline, isn't it? It really grabs you. And our mission today is precisely to go beyond just, summarizing that optimistic take. We want to critically examine where this technology is genuinely advancing and, crucially, what might be getting overlooked in the much bigger picture of e-waste.
Right.
Our goal is to uncover the nuances behind the headlines for you so you can really understand both the immense challenges and the exciting opportunities at play.
Okay, so let's start with the sheer scale of the problem because it's truly staggering and, frankly, it seems to be worsening.
Yeah, the numbers are pretty mind-blowing.
Imagine a line of lorries stretching bumper to bumper all the way around the entire Earth's equator.
Wow.
That's roughly the 62 million tons of e-waste we generated back in 2022 alone. But here's the truly shocking insight. Less than a quarter of that, only about 22%, was ever formally recycled.
Only 22%. That's remarkably low.
And the UN actually projects that number will fall to 20% by 2030.
Fall, not rise.
Fall, which is a really alarming trend, isn't it?
It really is. You'd expect it to go the other way with more awareness.
You would. And beyond the environmental disaster this represents, there's also this colossal economic drain. In 2024, an estimated $63 billion worth of recoverable raw materials, we're talking precious metals like gold and silver, rare earths, valuable plastics.
Right, the stuff we need.
Exactly. It simply went to waste, trapped in landfills, or maybe incinerated. By 2030, that figure is projected to skyrocket to over $80 billion.
$80 billion just wasted.
Right. This isn't just waste. It's a massive, accelerating economic and environmental leak. The Economist then pivots to, well, a fascinating potential solution. AI-powered robots.
Oh, the tech fix.
Yeah, the idea is they could be the answer to overcoming the traditional hurdles. Manual labor for disassembly is expensive, it's slow.
And dangerous sometimes, too.
True. And conventional robots, they just struggle with the sheer variety and complexity of modern electronic devices. But this new generation, powered by artificial intelligence, might just be up to the job.
It's a very attractive proposition, definitely.
Mm-hmm.
The current methods, they often involve crushing or shredding.
Right.
Which leads to what we call downcycling. That means materials get reused, but in a lower quality form, or they just get contaminated beyond easy recovery.
Okay.
High precision disassembly, though, promises to retain much more of that embedded value. You get cleaner materials back.
But this isn't just like futuristic speculation, is it? Some of these robotic solutions are apparently already making an impact in quite impressive ways.
That's what the article suggests, yeah.
The Economist points to Apple's system, Daisy, as a prime example. Just a decade ago, Daisy could only dismantle one type of iPhone.
One type, okay.
Now, with the continuous advancement of AI, it can efficiently handle 36 different iPhone models.
36, that's a big jump.
And processes around 200 phones per hour. What really caught my attention, though, is that Apple makes these disassembly patents available royalty-free.
That's interesting. Royalty-free.
Is that truly enough to move the needle for the wider industry, or are there still, proprietary hurdles even with open patents?
That's a great question. And look, it signals a positive intent from Apple, definitely, sharing critical recycling tech.
Mm-hmm.
While making patents royalty-free removes a financial barrier, the challenge often lies in the capital investment needed for others to build similar setups.
Ah, right. The cost of the robots themselves.
And the operational know-how. It's not just the patent, but the entire system, the software, the integration, the maintenance that needs replicating. Still, it's a strong step towards encouraging broader adoption, even if it doesn't instantly solve the whole problem overnight.
Okay. And it's not just Apple doing this kind of thing. Microsoft has its #NoShred initiative, which sounds equally compelling.
Yeah, I've read about that one.
Traditionally, data center hard drives are just crushed whole to irrevocably destroy sensitive data. Standard practice.
It's security, yeah.
Makes sense. But Microsoft is using robots to dismantle them so precisely that only the data-containing platters actually need to be shredded.
Ah, okay. Surgical.
which allows other valuable materials like magnets and various metals to be recovered instead of just being destroyed along with the data. Their circular centers achieved an impressive 90.9% reuse or recycling of servers and components in 2024.
Over 90% is really good for that kind of complex hardware. And it's not just these tech giants working in isolation, right? ABB, a major electrical engineering company, is collaborating with an American recycler called Moog
Whoa, yeah.
on robotic mini factories, specifically designed for dismantling electronics from these huge data centers.
Mini factories. I like the sound of that.
What's crucial to note here is the precision these systems allow. For data centers, the value isn't just the materials, it's also that secure data destruction.
Right. Can't mess that up.
Robots can achieve that surgical precision. It's much harder to guarantee with bulk shredding where you might, over-destroy or even under-destroy sometimes.
Okay.
This kind of targeted recovery is where the economic benefits really start to stack up, particularly for those high-value components inside.
But the ambition doesn't stop at specific product lines like iPhones or hard drives. In Germany, the Fraunhofer IFF has its IDEA project.
Yes, IDEA.
Which is aiming for something much more ambitious, a general-purpose system. They're starting with old desktop PCs, some more than a decade old. Talk about variety.
That's a real mixed bag. Much harder challenge.
Definitely. This AI-assisted robot can apparently identify a product using cameras, scan labels, search for service manuals, or even online videos.
Like using an LLM or something similar?
Exactly, much like a large language model would, to understand how a device is put together. It then analyzes all this info to figure out which components are worth removing.
Prioritizing, okay.
And generates a precise disassembly sequence, deploying various tools, drills, grippers, screwdrivers, the works. Dr. Sainz, who leads the team, says they're in the milestone early integration stage.
So still early days for that kind of general system.
Yeah, and estimates it could be 5 years until commercial general purpose use is widespread. That sounds incredibly complex.
It absolutely is. But what's genuinely impressive about the economist's framing here is that it truly captures where the technology is strong and genuinely advancing. First, these robots genuinely unlock higher value recovery. By precisely taking devices apart, they avoid those crushing contaminant methods.
The downcycling you mentioned.
Exactly, that often downcycle materials, meaning they're reused in a lower quality form rather than returned to their original value. We see this with the Apple and Microsoft examples. Better recovery of magnets, rare earths, other valuable metals. They can even preserve whole parts for reuse sometimes.
Okay, so real value creation there.
That's a real efficiency and value gain, especially, as we said, in controlled environments where you know what's coming in.
Right.
Second, AI does address what we call the long-tail knowledge problem. Traditional robots just get stumped by the thousands of different devices out there.
All the different screws and glues.
Exactly. Each with unique fasteners, glues, internal layouts. But modern AI, capable of pulling service manuals, reading product labels, analyzing CAD data, planning complex sequences in real time.
That's where it shines.
That's exactly where advancements in areas like large language models and computer vision truly shine. The IDEA project is explicitly building that capability. So the research to industry transfer here is plausible, I think, and incredibly exciting. It's like giving a robot a highly intelligent, real-time instruction manual for practically any device it encounters.
Okay. While the tech is undoubtedly exciting and the progress is genuinely impressive, this is where our exploration truly begins, right? Because beneath these impressive headlines, there are crucial questions and, well, overlooked realities that need addressing before these robots become the ubiquitous solution we hope for.
Indeed. Yeah, while the robots are powerful tools, very capable, we need to ask ourselves if we're maybe putting the cart before the horse a little bit.
How so?
The capabilities are growing, yes, but the wider ecosystem, the whole picture, still presents some really significant hurdles.
Okay, let's dig into those.
A collection is the binding constraint, not just disassembly. What's fascinating here, and maybe a bit sobering, is that even the most advanced, smartest robots, they can't help if devices don't even reach formal recycling channels in the first place.
Right, that old phone sitting in your drawer.
Exactly, or the discarded laptop in your garage.
Yeah.
Globally, the UN projects the documented recycling share to drop by 2030, not increase.
We mentioned that drop earlier, yeah. It's counterintuitive.
It is. Most e-waste still ends up unmanaged in general waste streams, maybe shipped overseas to informal sectors. This raises a really important question. What about robust bring-back systems? better consumer incentives, like maybe deposit refunds,
Things to actually get people to recycle properly.
and truly effective extended producer responsibility, or EPR enforcement, where manufacturers are actually held accountable for the end of life of their products. Without these fundamental pieces getting the stuff to the recyclers, any efficiency gains from AI-powered disassembly, however impressive they remain largely niche, solving a problem for only a fraction of the waste.
So we can build the smartest robots in the world, but if the devices don't even make it into the recycling pipeline,
The robots are sitting idle, essentially.
the robots are solving a problem for a fraction of the total waste. It sounds like a huge logistical and, well, behavioral challenge.
Exactly. It's a supply problem that automation just can't fix on its own. Then there's the issue of how products are actually designed in the first place.
The design aspect.
B. Product design often defeats automation and humans. If we connect this to the bigger picture, many products are simply not designed for disassembly. Not at all.
Like glued-in batteries.
Think about those glued-in screens and batteries,
Yeah.
Hidden fasteners you can't see or reach easily, or even software parts pairing.
Parts pairing, what's that?
It's like a digital lock. The device's software ensures it only accepts original manufacturer components. So if you try to put in a third-party battery or screen,
It just won't work.
it might not work, or certain features might be disabled. It effectively blocks third-party repairs or refurbishment using non-original parts.
Wow.
These design choices create huge hurdles, not just for us trying to fix our own devices, but even for the most sophisticated robots. Imagine an AI robot meticulously planning a disassembly sequence, only to encounter a battery that's essentially epoxied into the chassis.
Yeah, what does it do then?
It dramatically slows down the process, increases the risk of damaging the battery or other parts, and makes the whole operation much more costly. Now, the EU's battery regulation, coming by February 2027, will require user-replaceable portable batteries.
That sounds like a big deal.
It is a much-needed systemic fix, but until then, truly universal disassembly remains painstakingly slow and incredibly expensive because of these design choices.
So we're asking these sophisticated robots to do what many of us struggle with, just opening a cheap plastic toy sometimes. The design choices almost seem intentionally hostile to repair, whether it's by a human or a robot.
It often feels that way, yes.
Yeah.
It's a critical upstream problem that needs solving. And speaking of challenges, there's a really serious safety issue that automation has to confront head-on. Safety. The elephant in the room is Li-ion batteries, lithium-ion batteries.
The fire risk.
Exactly. Fires caused by damaged lithium-ion batteries at recycling facilities are a growing and serious problem. It increases costs, safety risks, and it can even shut down operations significantly.
I've heard stories about recycling trucks catching fire.
It happens. These batteries are everywhere now. Phones, laptops, e-bikes, scooters, you name it. And when they get damaged during collection, transport, or even during disassembly,
Boom.
they can ignite explosively. Any automated line must solve safe battery identification, removal, and neutralization at scale before it can truly take off.
So the robot needs to know what it's handling and how to do it safely.
Absolutely. This isn't just a technical detail. It's a fundamental operational challenge. It could halt entire facilities if not addressed proactively and robustly.
That's a stark reminder that we're dealing with more than just precious metals. There are inherent dangers baked in. It adds a whole new layer of complexity to the robot's job description.
Absolutely.
Yeah.
The robot isn't just disassembling. It's potentially navigating a minefield. And then there's the cold, hard reality of economics. Does it actually pay?
Right. The bottom line.
Economics and scope. When does this actually make sense? While Apple's Daisy and Microsoft's focused HDD lines show undeniable success, remember, these are what we call narrow domains.
Meaning?
They involve high control over the incoming products. They know exactly what they're getting, a limited number of product variants, and high value per unit. Apple only deals with iPhones. Microsoft deals with its own data center hardware.
Okay, controlled streams.
Now contrast that with the incredibly heterogeneous stream at a typical municipal e-waste site. You've got thousands of different products, varying ages, countless conditions, all mixed together.
The complete jumble.
This immense complexity severely challenges cycle times for the robots, the constant need for tooling changes, and ultimately, the return on investment, the ROI. This is precisely why those general-purpose robots, like a deer, are still largely in the lab. The economic model just isn't there yet for the anything-goes stream of consumer e-waste.
So if you're a municipal recycler, you can't just buy one of these advanced robots tomorrow and expect it to magically sort through every type of discarded gadget from the last 2 decades. The complexity makes it a logistical and financial nightmare.
Precisely. The upfront investment versus the often low and inconsistent value recovery from that mixed stream makes it a really tough sell for general recyclers right now.
Wow.
And finally, we need to consider the broader impact, the bigger picture.
Okay.
E-robots is a downstream band-aid for upstream obsolescence. This raises an important question. If device refresh cycles remain short, driven by consumer desire for the latest model, or maybe software updates that dictate a device's usability.
Making older devices slow or incompatible.
Exactly. Then even improved disassembly technology risks becoming just a downstream band-aid. We're getting better at recycling things that are fundamentally designed to fail or become obsolete quickly.
Addressing the symptom, not the cause.
Right. The bigger wins for genuine sustainability are actually longer device lifetimes, true repairability by design, and robust secondary markets for reuse, where products get a second or third life.
Keeping things in use longer is better than recycling them efficiently.
Generally, yes, from an environmental perspective. And these are areas that new EU regulations are also explicitly targeting, suggesting that policymakers see them as much larger levers for true environmental impact than simply efficient end-of-life processing alone.
So while the robots are brilliant, potentially they might be addressing a symptom, not necessarily the root cause of our consumption patterns and design choices. It sounds like there are significant hurdles, definitely, but also some powerful forces at play pushing things in the right direction, especially through policy.
Absolutely. And that policy side is crucial. We're seeing some really important policy tailwinds that could dramatically impact the landscape. The EU's Right to Repair Directive, adopted back in April 2024, is set to extend guarantees after repair and significantly improve access to spare parts.
Making repairs easier and more attractive.
Exactly. It directly nudges us toward reuse and repair before recycling, keeping products in use longer. That's a big shift. Then, from June 20th, 2025, new EU eco-design and labeling rules for smartphones and tablets will mandate durability and repairability labels.
So you'll see a score on the box.
Potentially, yes,
Yeah.
or some clear indication. And it sets deadlines for spare parts availability. This means when you buy a device, you'll actually see a rating for how easy it is to fix.
I could really influence buying decisions.
Hopefully. And push manufacturers to design better from the start.
Okay, what else?
Even more significantly, perhaps, the Digital Product Passport, or DPP, is coming. This can be a real game changer.
Digital Product Passport.
Yeah. It could provide robots and humans doing repairs with the precise metadata they desperately need for efficient and smart disassembly. Imagine a robot scanning a QR code or an RFID tag on a device and instantly knowing exactly what materials are inside, where they are, how they're fastened.
Like a digital instruction manual for that specific item.
Exactly. Just by accessing this digital passport for that specific product, it takes away so much of the guesswork. And crucially, that EU batteries regulation we mentioned, it will require user-replaceable portable batteries by February 18th, 2027.
That specific date is locked in.
It seems so. This is a direct fix for that major problem of glued-in battery that currently impedes both human and robotic disassembly. It makes everything safer and much more efficient.
Wow.
These policies aren't just setting the stage. They're essentially reshaping the products themselves over time, which will make the robot's job much, much easier down the line.
So when you hear future claims about AI robots revolutionizing recycling, it sounds like there's some really practical skeptics checks you can apply to gauge the reality of the situation. What should we be looking out for?
Precisely. Yeah, thinking critically about the claims. Here are maybe 5 things to consider. First, is the input problem solved?
The collection issue.
Right. Are there concrete measures being implemented? Deposit refunds, mandatory take-back schemes, effective public awareness campaigns that genuinely make a difference in getting devices into the system? If not, the gains from automation will likely remain niche.
Okay, check 1. Collection.
Second, is there true design for disassembly? Are batteries actually removable without needing heat guns or solvents? Are fasteners standardized and visible? If yes, robots will fly. If no, expect bottlenecks and high costs, at least until those 2027 EU battery rules really bite and manufacturers adapt their design significantly.
Check 2. Design. Got it.
Third, is there a robust safety plan for batteries? We need scaled battery detection, safe removal, neutralization, and fire mitigation technologies that are proven and operational in these facilities.
Not just theoretical.
Exactly. If that's missing, automation pauses, potentially catastrophically, when not if damaged battery packs show up in the waste stream.
Check 3. Battery safety. Makes sense.
Fourth, what's the scope control? Is the robotic line SKU-bounded, meaning it handles specific known products like iPhones or data center hard drives? Or is it an anything-goes system trying to tackle mixed municipal waste?
The narrow domain versus the Wild West.
Pretty much. The return on investment is far better in the former today, and it's a good indicator of where the technology is truly viable now.
Okay, check 4. Scope.
And finally, number 5. Is the data layer ready? Will things like digital product passports or repair labels actually feed robots reliable teardown metadata? Or are they still relying mostly on computer vision to guess what's inside and how to take it apart?
Data availability.
That's the difference between impressive lab demos and reliable factory-grade uptime day in, day out.
Those are really helpful checks. It's clear that the economist is absolutely right, that AI robotic disassembly is real and advancing at a remarkable pace, especially, as you said, in those controlled environments and for high-value items. But as we've discussed, the article perhaps slightly overweights the fascinating tech itself.
Yeah, the shiny object.
And underweights the systemic foundational challenges. Everything from getting the e-waste to the robots in the first place, to how products are designed, and the absolutely vital role of policy in shaping all of this.
It's a powerful tool, the robot, but it's definitely just one part of a much larger, much more complex puzzle that requires a holistic approach.
Absolutely.
So maybe the provocative thought here is, the real game changer might not be just the robots themselves, however smart they get. It might be whether policymakers and manufacturers truly translate these new regulations, red repair, battery rules, DPPs, into practical design standards and genuinely accessible data.
Making it real on the ground.
Exactly. Will you, as a consumer, be able to tell if a company truly embraces repairability and ease of recycling when you buy your next device? Or will AI robots remain a fascinating but ultimately niche solution for a growing global problem that really requires broader systemic change?
Something definitely to think about next time you upgrade. Thanks for listening. Follow us to stay updated with the latest insights on The Economist every day. And don't forget to like, comment, and share.